Should I start calling names? Okay, I'm having Sam Manuel De Sousa. I'm having Chief Samuel Raimi. I'm having Elder James Daniel. I'm having let's talk please. I'm having Ajia Adegoke Aliyah. I'm having Sister Eniola Dorcas. I'm having please, how do I pronounce this? Omo. How do I pronounce that your other name? Please, can we hear me? Nobody is talking. No. Hello. So I okay, so which of the problems should we start with? Please, let's just dive into the problem straight away. Don't let us waste time. Which of the problems should we start with? I sent 3 questions on the group. Or if you have if you have questions from your hand. Okay. The third one. Okay, I'm going to tag it just to be sure. Okay. And if you have questions from your hand you want us to consider, please kindly send it in. Okay. So that one I tagged just now. Check the WhatsApp group. That one I tagged, right? The anti-vibration mount. I think that's the title for it. The anti-vibration mount. Okay, let me share this. Okay, can we see my screen? Everyone, if you can see my screen, let me know, please. Just talk. If you can see my screen, let me know. Alright, thank you. Okay, this. Alright. Now, one thing is this, I don't know what will actually come out in your exam, but one thing I'm sure is that if the man told you that if you can attempt any of these questions perfectly, then you are good to go for your exam. Yeah, it might not actually repeat the same question, but it might give you something similar. Do you get it now? It might not repeat the same question, it might give you something similar. So that's just it. So if that is the case, I'm going to actually cancel this one out. There is this particular question, this one. So just take this one out. I'm pretty sure it won't give you something like this because of this first component here. So even though the man is actually he had somebody, you get, it won't be hard to give you something like this. Yeah. So if we have time, we are going to consider this. I think I did this already. I have this on my PC already. So straightforward. The only one that's actually added here is this first component here. But I'm pretty sure. So this actually come out. If he's going to repeat question, this might come out. This one is straightforward. Okay. These two might come out. This one is also straightforward. This is straightforward. This is straightforward. This is straightforward. Okay, so let's start with this. Okay, let us start with this. So I'm going to actually start from one of the cheapest components there. Let's start from component number 4. All right, component number 4 now. If we look at the details given to it, it says a semi-finished hexagonal bolt M16. So M16, some of you might actually be aware of what it actually implies. So M16 actually means this threaded part. Oh, sorry, I need to actually bring this out so that I can use this to illustrate. Okay, it's incredible. So okay, so now this area, do you see the area I'm marking? Can you see it? Hello? 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 Respond now, I beg you. Thank you. Thank you. So this area that I marked now, that threaded part, okay, that's the meaning of the M16. So the diameter of this road here, this boot from here, okay, is diameter what? 16. Okay, so whenever you see M, just know it is what? A threaded part, a thread. So this stuff you are seeing on the body is known as a thread. Okay, so whenever you see M8, M16, M12, M this, M that, just know it is what? A threaded part, and the diameter is what? Is 16. So that is what that area actually implies. All right, so we are going to recreate this particular object now. So, but before we actually do, I'm going to actually create this head first of all. Okay, and if you've actually watched my video, I think you should be able to create this part. Okay, but just for the sake of those who aren't familiar with it, let's go all over again. Okay, now there are some instances whereby you are going to just assume dimensions for yourself. Okay, now for example, now the head of this particular board, now we are not given the length of this head either across corner or across flat. I'm pretty sure you did that in MEG 211 hexagon, across corner and across flat. So the distance from here to here is what? AC, across corner. That's the distance there. So now in this scenario, we are not given any dimension for across corner or across flat, so we are going to just assume. And what I do use in this case is I add dimensions of either 10 or 14, yeah, to the initial dimension of the boat. Now, as this one is M16 now, I'm going to add 10 to it. That's going to be what? To get this hexagonal head, that's going to be 26. And to do that now, so I'm going to, okay, let me create a project file. I'm pretty sure we cannot create a project file, right? Can we create a project file? Let me create a project file for this sake. Okay. Okay. I'm pretty sure what I'm doing on the screen, we all know how to actually get to that area from our respective laptop. All right. So now to create that M16, whatever waiting. So you are aware you can pick any of the plane. You can pick the XY, you can pick the YZ, you can pick the XZ. All right. Please, if you have any question along the way, don't hesitate to unmute and ask. Please. All right. Don't hesitate to unmute and ask. So now I'm going to pick a polygon. Okay, I'm going to draw this. So M16, I am adding 10 to it. That's going to be what? 26 for this edge. 26, like that. And I'm going to what? Finish my sketch. You see that? So I'm going to extrude it. So we are not giving the thickness for the head also. I'm going to just assume. So I'm using 10. Okay, so I'm going to click on that face, create a new sketch. Please, if you have any problem or any question, don't hesitate to ask. Please and please and please, don't hesitate to ask. All right. Now with my extrude, I think I have a video on how to actually create this boat of 18, so that shouldn't be an issue. Yeah, both are not, that shouldn't be an issue. Okay, but I can continue like this. Okay, then our M16 right there. So now if we look at the problem, okay, the length is what? 110 long. 110 long. From here down here, that's 110 long. Okay, I'm going to actually extrude this to 110 now. 110. Then what? Okay. Now looking at it like this, the next thing is I'm going to create that hole you are seeing. You know we have a hole. This hole you are seeing here, this hole of the diameter 4.5 drill. Yeah, I'm going to create that hole there. Okay, I'm going to create that hole there. Now how do I create that hole? So I'm pretty sure you are aware that in Autodesk Inventor, I have a flat surface like this. I can click on this flat surface and create a new sketch. That is very, very possible. But on cylindrical surface, that is not the case. If I want to create a new sketch on a cylindrical surface, I need to actually create it by using a plane, okay, by slicing through it. And now, coming to my origin here, I have access to several planes. You see, YZ plane, XZ, and XY. So I'm going to pick either XY or what, or YZ. Okay, any of the two will actually give me that whole of diameter, what, 4.5. So let me just pick this. Okay, so I'm going to slice it to see the inside. So when you press F7 on your keyboard, it's going to slice it open. So that is dividing it into 2 equal halves for you. You see that? So that is it. I use F7 key, the function key on your keyboard, F7. Alright, so I'm putting a hole of 4.5. Okay, and the distance from the edge here to the middle of that hole is what? Is 9. Take note. The distance here is 9. So with my dimension, I put what? 9. Then I what? Finish my sketch. Finishing my sketch with my extrude. I do this symmetric. We actually know what symmetric is, yes or no? I need answers. So, do we know what symmetric is? We have, yeah, when you want to extrude, we have this first one, that's default. We have flipped, we have symmetric, we have asymmetric. So, do we know the difference between this symmetric and asymmetric? Do we know the difference? Hope you guys can hear me. Okay, so I said, we know? Okay, thank you very much. So I'm going to use my what? Symmetric. Then I'm going to use what? Through all. Then I'm going to what? Cut through. So using that with my okay, I have the hole right there. You see, that is as cheap as what? Plantain chips. Easy as ABC. Okay, easy as ABC. So that is that about that. So now I'm going to actually do the thread. So now we are told that the thread is what? 30 from the tip here to the inside is what? The thread is what? Is 30. Is 30. So I'm going to do that now. Offset at 30. So with my okay, yeah, I'm recording it from my end here. Don't worry, I'm going to share the link with you after the class. So from here, all right, depth of what? 80. You see, that's it. What? Okay, you see that? So now, if you look at the tip of this boat, it is chamfered a little. It is chamfered a little. Though now, in some cases, you'll be given the dimension for the chamfering, and in most cases, it's usually 2. You will see 2 times 45 degree. Whenever you say 2 times 45 degree, know that is what? That's the chamfer. All right. So in MEG 211, the lecturer actually differentiated between a chamfer and a fillet, right? Hope you can differentiate between a chamfer and a fillet before I proceed. Can we differentiate between a chamfer and a fillet? Chamfer, fillet. Do we know the meaning? Eh? Okay, thank you very much. Then we move. So I'm going to just chamfer this at a distance of 2. Yeah, I think that's okay. Then what? Okay. Alright, so I'm going to save this as item number 4, as it is on the question, item number 4. Okay. Now, all the FEC, blah blah blah. Note of this. All this FEC, picking of material, blah blah blah. In exam time, you don't need that. When you are done with your work and you still have time, you can do that. Okay. So nobody is eating your, yeah. If you actually give it the right material, it looks good. So you get, when you look at it aesthetically, it is okay. But that is time. But if you can do that without changing yourself when it comes to time, no wahala. So let me ignore that for now. Maybe after assembly I can do that. So with my Control N, I have this, and I create another part drawing file. Yeah, if you can't see the video again, that's network issue. That's network issue. Sorry, from your end, I think, or from my end. I'm not even sure. So now let's produce item number 3. Now look at this item number 3. It says bush. Item number 3. It says what? Bush. You see, bush, and the material for this bushing is what? A rubber. And we are told that we are to have 2 pieces of this. That is made of these 2 required. Meaning 2 pieces of this what? Of this bushing. 2 pieces of this bushing. Okay, 2 pieces of that bushing. That is it. So let's create that. So now for this bush, we can create it using 2 means. I can create it using extrude. I can create it using revolve. Are you listening? We can create this bush using what? Extrude and using revolve. Now let me actually chip this in. Now looking at this bush, you are going to take note that all the shape we have on this bush is what? Is a perfect circle. So if you are doing any shape that has a perfect circle throughout, you can actually make use of extrude. Okay, but if your shape is cylindrical but it is not a perfect circle throughout, let us assume maybe it is giving you something. Let me look for one funny question like that. I'm coming. One moment, please. Let me see whether you can find it here. And now, okay, hey, for example, now look at this particular item here. Look at this particular item that my the cursor of my mouse is hovering about. Now, this item is also a cylindrical shape item, but it is not perfectly cylindrical from top to bottom. So now in this case, now I can't use extrude here. I am going to use revolve. If you want to create this particular item, it is revolve we are going to use. We are going to use what? We are going to use revolve to create this. Because if you look at the shape here, yeah, this is a tapered shape. Tapered. Okay? Tapered. This is a tapered shape. All of you are saying you can't see. I can't see the video. I can't see the video. Okay, let me confirm from my end. Can anybody see the video from his or her end over there, please? If you can see the video, if you can see the screen from your end, kindly let us know, please. If you can see the screen. Okay, so those of you who can't see, you are using your network is fake. So get MTN, original MTN, not roadside MTN, original MTN. Don't use Airtel or Glo. Sorry, sorry. So for those who are using original network, so let us move. So those of you who can't see the screen, you can disconnect. Switch on the airplane mode of your phone, then switch it off, then connect back again. You should see it by then. So it should pop up. Okay. Now I said this area here is a tapered object. It is not a perfect circle. This area here is really, it is something like this. Something like this. Okay. I think that is not doing justice. Let me draw it. So it is something like this we are having here. So a bigger circle here, a smaller circle here. So I can't use extrude for this one. I am going to use what? Revolve to get those kind of shape. So take note of that. So whenever you come across object that is not a perfect circle throughout, just know that what you are using, what you are using revolve. So, and that is one of the clue to solving your problem. Okay, when you know what to use, then you are one step closer to finding solution to whatever problem you encounter during the exam. Okay, so while you already know what to use now, because if you are saying this now, you are thinking, oh, it is extrude I want to use, you keep wasting time. You keep drawing, deleting, drawing, erasing, drawing, deleting, because extrude won't give you this particular object. So take note of this. If your object is not a perfectly cylindrical object throughout, you are using what? Revolve. But if it is perfectly cylindrical all through, you can use what? Extrude or what? Or revolve. If it is perfectly cylindrical all through, you can use either extrude or what? Or revolve. But if it is not perfectly cylindrical, you can only use what? Revolve. All of that. So for this particular bush, I'm going to use the 2 methods. I'm going to use extrude. I'm going to use revolve. Alright. Now, when it comes to Inventor, basic mathematics, yeah, you have basic mathematics there. Just do your plus and minus. You get. Because I might be saying this 20, this, you'll be saying, how did they actually came about 20 and this? So, me, I'm trying to use balance that small, so I calculate it on my head. And I'm pretty sure you are aware that Inventor can also calculate. So if you can't calculate on your head, just press it on it. This plus it is going to what? Give you the correct answer. Alright. So let me use revolve. Sorry, let me use extrude first of all to create one of the bush. Now this bush that says 2 is required, I don't need to create it in 2 places. So I only need 1. If I create 1, I can duplicate it when I want to assemble. Take note. This bush now is saying I need 2, but I am only going to produce 1. Then I'm going to duplicate it when I want to assemble. So don't say since the right 2, let me produce it 2 times. You are wasting your time. So let us imagine they say this bush you need 7. Are you going to recreate it 7 times? No, that's waste of time. So when you create 1, you can duplicate it in 7 times, 8 times, or nth time. So take note of that. All right, take note of that. So, but for the purpose of this class, I said I'm going to use revolve. I'm going to use extrude. That's why I'm going to create it 2 times. Under exam condition, I'm only going to create 1. Then I move on. Take note of that. So the dimension for it, for extrude, diameter 36 here at the back, diameter 50. Then on the inside, diameter 16, 36, 16, 50. Take note, 36, 16, 50. Use any of the plane, okay? With my circle, diameter 36 from the origin, you see, diameter 16, okay, and diameter what? Diameter 50. You see that? Then what? Finish sketch. Finishing my sketch. Now, one thing is this: the reason why most of you actually find it difficult to produce objects is this. After creating your sketch, you have the sketch flat like this. If your sketch is flat like this, it is going to be hard for you to know where you are extruding to. Okay. Now, look at this area. Thank God I even remember. Look at this area. Yeah. That is your view cube. So, if your view cube is giving you only 2D, that is length and breadth like this, anything you are extruding or revolving, you won't see what you are doing, and you can make mistake. So before you extrude or revolve, ensure that this shape here is giving you a 3-dimensional view. Okay, it is giving you what? A 3-dimensional view. And how do you set it to 3-dimensional? It is quite easy. So if you carry your arrow, the cursor of your mouse, to the edge, you see, to the edge here, to the edge at the bottom, to the edge at the bottom, it is going to give you what? 3D. Let me try this place. You see. Now you can see that even the icon is giving me what? Isometric view, 3D. Unlike this one that is only giving me what? 2D, length and breadth. Now if I pick here also, it is giving me what? 3D. I have length, breadth, and what? And height. So take note that your view cube is in pictorial form, is in 3D form before you extrude or revolve, so that you can see whatever you are doing. So take note of that. Take note of that. And if you don't know how to use this view cube, if it is hard for you, you will actually need an external mouse. If you want to enjoy Inventor, you need an external mouse. Now there's a way you can actually revolve this object here. Okay, move it about with your external mouse. So if I'm using an external mouse now, a 3D-button mouse. So if I press down the scroll button of my mouse, of my 3D button, that scroll button, that button I'm using to scroll in, scroll out. Okay, if I press it down, you see, I can what? I can move my object. You see that? That is pan, P-A-N. I can pan it and what? And move it about. Okay. Now, if look at this scenario here now. If I want to actually change the view of this particular object without using this view cube, using my mouse, all I have to do is what? I'm going to hold my shift button. If I hold my shift button, I'm going to press down my scroll button. Scroll button that you scroll in and out like this. So press down your shift button, hold your scroll button, and see. You see, you can also revolve your object about. You can do orbit. You can orbit your object about. Do you see that? You can orbit it about, because some people will say, to use mouse to control this thing is difficult. So that's another way you can actually use to control this thing. Hold down your shift button and hold down the scroll button and what? And just move your mouse. You see, clean like Maekll, cheap like what? Like plantain chips. Right. So back to this. I'm going to extrude this now. If we look at this object, that's diameter 36. Diameter 36 is coming from the bottom. Okay, it's coming from the bottom, and the dimension there is 25, and from the bottom is what? 4.5. 25 plus 4.5, that's 29.5. So this one, 29.5. Okay, with my plus here. Okay, I click the plus right here. Okay, and that bottom, that diameter 50 is at thickness of what? Thickness of 4.5. Thickness of 4.5. This at 4.5. Okay, then what? Okay, so I have it. You can see, deep like plantain chips. with my shift button held down and my scroll button pressed down. You see, I can orbit this object and look at it from different view. Here you see, that is it. Clean like Maekll, cheap like plantain chips. So they said they use rubber. Sorry, let me use rubber for it. Let me come to my material here. Rubber, where are you? Rubber. That is it. Let me make it real. View. Visual style, realistic. Cheap. Fantastic, isn't it? So that's my item number what? Item number 3. Let me name it as 3A. Okay, now I'm going to use revolve for the same object. For the same object, I'm going to use revolve. Okay, I'm going to use revolve for the same object. So if I'm to use revolve, Control N on my keyboard. Control N. Okay, then what? I have this interface. Now, if I'm going to use revolve for this object, take note of this. If you want to use revolve, you need to actually produce that object half orthographic view. Half orthographic view. What do I mean by that? Now look at this particular object now. Okay, look at this object. So you know the orthographic of this object lying down is going to actually look like this. If I take this area here as my front view, if I take this direction as my front view, I will be having it like this. Right? And this hole on the inside is all true, so it will be hidden like this. Am I correct? Before I proceed, am I correct? Hello, Chim. Okay, thank you. So hidden view like that. So now if I'm going to produce this object using revolve, all I need is just half. No, there are several techniques, but the technique that I actually mastered that looks best is I will just divide this object into two and pick any half, either the upper half or what, or the bottom half. Then I'm good to go. Now in this case, now this hidden view won't be hidden any longer. I'm going to make it visible. Yes, because me, I don't like to waste time. Some people will first of all do it revolve, then create another sketch. I'm pretty sure the lecturer will have actually informed you guys that if you should try as much as possible to ensure that this your information bar, this area here, is not too clogged. Yeah, if there's a way you can actually do it such that you don't have plenty data here, your lecturer must have actually informed you about that, and that is what I try to do anytime I want to draw. Okay, so I just think of how do I make this drawing cheaper? How do I draw it faster without wasting time? Yeah, if it's possible for me to just use one sketch and create the whole thing, I will go for it. So that's it. Alright, so now that particular view, to generate it, I'm going to actually stand it up. Okay, I'm going to stand it up like this. Instead of making it sleep, I'm going to do it this way. Okay, like this and like this. That's half. You know that's half of that object now, Abby. That is the half of it. They have it like this. Yeah, that's half of that object. That's half of it. So I'm producing half. So with that half, I'm going to add my dimension. Okay, I'm going to add my dimension. So we are told that this is diameter 50. Now half of diameter 50 is what? 25. Enter. Okay, this place, the height is what? 4.5. My height is going to be complete. It's only diameter I'm going to divide into 2. Okay. Okay, that place is 25. This place is 25. This place is that will be 18. 18, and this place is 16. This is going to be what? It's going to be 8, and that's it. With this now, I finish my sketch. Finishing my sketch, I pick what? Revolve. With my revolve, I pick this area my axis, this is going to be my axis, then I have the same object. You can see chip like what, plantain chips, still the same object but using different technique. So take note of what I actually said earlier on. If your object is a perfect circle, you can make use of what, extrude. But if it is a cylindrical object but it is not a perfect circle, you are using what, revolve. Take note. But you can use revolve for both perfect and imperfect circle. You can use revolve for both perfect and imperfect circle. You can only use extrude for perfect circle. So take note of that. Alright, so I don't need to save this off. No job. So Control N, I have another working page. So let's create item number. Let's create this yoke. Look at this yoke. So this yoke now, if I want to do it from my end, there is a way I can actually create this yoke using just one sketch. Okay. Now, should I show you how to use just one sketch to generate this yoke? I only sketch once. I'm going to just sketch once. I won't create another sketch any longer. Just one sketch. Should we do it that way, or we should use multiple sketch? I need option. One sketch. Okay, now if I'm going to use one sketch, I'm going to actually view it from this direction. If I view it from this direction with one sketch, I'm going to have it. Okay, if I'm viewing it from that direction, you know, this is what I'm going to be having. I'll be having this orthographically like this. Okay, let me use this line. I'll be having this pam, 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 like this, and this circle here like this, isn't it? Now you'll be wondering, he said he's going to use one sketch. How is he going to do it? Yeah, this hole you are seeing here, this hole here, and this hole here, I can actually generate it using revolve. That's what I'm going to do. Okay, I'm going to actually use revolve for it. Okay, and now let's go. Let me just show you. Okay, let me show you how to generate that using just one sketch. Okay, so with this, pick any plane. I'm picking this. All right. The outside here, radius 27. That's diameter 54, 54 and 21. 54, 21. Okay, then I have this like this. Okay, now look at this. Now you will notice that my line here, the line I drew, this horizontal line here that I circled, this one here, you can see that that line is not straight. Yeah, so whenever you come across something like that, you don't need to delete your line. Just calm down, relax. That line is not straight because it is not perpendicular. You can see I have a perpendicular constraint here, or no perpendicular constraint here. So what am I going to do? I'm going to pick my perpendicular constraint. You see, perpendicular. Bam, I click on it, and I'm going to click what? This and this. Here you see, that was it. Chip like what? Like plantain chips. Okay, so all right, I'm going to extend this line all the way to the bottom here. Bam, like that. Okay, then look at the dimension here, everybody. Look at the dimension from here to here. So from this edge here to the center of this circle here is what? Is 15. From the center of this circle now to the center of this circle is what? Is 36. If I'm not mistaken, that's 36. Okay, 36. That place is 36. Now the other end here, this place to this place will be what? Is going to be 20, because the diameter of this area is what? Is 40. So half of 40, this place to this place is what? Is going to be 20. That's it. So which means 15 plus 36 plus 20 in that order. 15, 36, 20. So from this area like this, 15, 36, 20. So let me use Inventor to calculate it to get the direction of that place. So if you are going to use one sketch, you just need to be calculative. Okay, 15, 36 and 20 from here to here. 15 plus 36 plus 20, enter. So we have that over there. So I'm going to actually get that mark 15 itself first. Okay, and this here. So now from here to here is 15, enter. From here to here is what? 36, enter. You see that? Now if I look at it from this, the hole at the center of this 15, the hole there is what? Diameter 20. That will be radius what? Radius 10. So I'm going to pick my offset. I'm going to offset this line like this at the distance of what? 10. Enter. And this one also like this, distance of what? 10. Enter. By the time I revolve it, I'm going to revolve this line now. From this will be my reference point. Okay, I will revolve this thing like this to give me perfect circle here. 1. This will be my reference point also. I will revolve this one like this to give me second perfect circle. 2. You get what I'm going to do right there now. That's what I'm going to actually do when I want to turn it to 3D. Take note, I'm going to revolve it about that axis like that to get those two holes at the middle there. That's what I'm going to do. Take note of that. Okay, so the height is from the center down there is 35 and the thickness is 8. 35, 8. Here to here is 35 and here to here is what? Is 8. Alright, so I think I can trim this also. Yes, and I can, let me extend this one all the way to the bottom there. I think I'm okay like that. So I'm going to actually move this thing to my origin. So from here to our origin right there like that. So I think I'm good to go. Let me check the dimension. Am I good to go? Good to go, good to go, good to go, sir. Yeah, we are good to go. We are good to go. So I'm going to finish my sketch. Finishing my sketch, I'm having this like this. So take note, everybody, take note. So with my extrude, okay, 80, is this 69 or 89? This is 69. So from the inside here to the inside here is 69. You now have thickness of 8, thickness of 8. So that will be 69 plus 16. 69 plus 16. 69 plus 16. And I'm going to use symmetric. I'm going to use symmetric for this place and this place. Do you see that? For that and that. I'm going to use my what? Plus. I'm going to pick only this place now. At what? 69. I'm going to use symmetric. I'm going to use what? Cut. Do you see that? And I'm going to use my plus again. So since this area is diameter 40, I'm going to pick everything here. This, and this at what? 40. I'm going to use symmetric. You see, 100 at the center. And I'm going to use yeah, okay. I'm going to okay it. Do you see that? Clicking on my object, showing my dimension, showing my sketch. Yeah, I'm showing my sketch. Now I'm going to come here like this so that I don't make mistake. Now I'm going to pick my what? Revolve. I'm going to revolve that shape. You see that first shape I did earlier on. So let me turn it to 3D so that I can see. So this first shape I did here, I'm going to pick that, select my axis about this axis here, using what? Cut. You see that? Then plus again, I'm going to pick this shape, my axis about this area with what? Cut. You see that? Then what? Okay. So I can hide those dimensions. Okay, with my fillet at radius of 20, As a radius of 20, I have this and what? This. Perfecto. Alright. I think I'm having this needs to be 4. Let me confirm. Yeah, the inside here, radius 4. The outside here, radius 12. Take note. So inside here, 4 and what? 4. Then outside here, that's what? 12. That's going to be this, and this, and what? Okay. So we have our object. Any question before we proceed? You can see cheap like what? Plantain chips. Easy as what? ABC. Any problem before we proceed? Please, if you have question, ask. If you don't understand, ask before I move on. 1, 2, 3, 4. No question. We move. Okay. So this is item number what? Item number 2. Item number 2. Please, if you have question, ask who. Yes, what is happening? I feel. So item number 2. Okay. So with my control N, so let's create this item number 1. Okay, body cast iron. 1 required. Body cast iron. Okay. This item number 1. Now, if you have objects like this, okay, if you have objects like this, the first thing you need to take note of is from which particular view will I get this object perfectly okay. Alright, now you won't tell me that if you want to produce this item number, even this item number 2 that we did just now, this item number 2 and this item number 1, you can't tell me if you want to produce this object, you are going to produce it from the plan. It's a default line. You will sleep there tired. Yes. If you take it from the plan, it is going to give you a lot of stress. So the best bet for this kind of object is from the what? From the front view. It's from the front view or end view. Your choice actually. Okay, now this item number 1, I'm going to actually consider it from front view. Okay, from this particular view here, this direction. Yeah, because that is the direction that is actually giving me what? This fine shape here. And I'm going to actually correct the rest from the plan later on. Okay, so I'm going to produce it from that direction first of all. Alright, so and take note of this. Each of these objects can be produced using several views. Okay, so don't say because I produce this one from this front view, you must produce one from the front view. Yeah, you can go with the plan. That is why the lecturer will actually tell you that all of you can't think the same way. Alright, and now let me correct this notion of a thing. Okay, so if you copy, the man will know. Alright, so even if you have only one computer and 3, 4, or 5 of us use that same computer, if we did not copy, the man won't have any issue with you. Yeah, so all this issue of one computer for one person, one computer for one person. Okay, you imagine like 30 of us are using HP and we did not change our admin name. You get it now? We did not change admin name. So my own system admin name is HP, your own is HP. Now if like 15 of us, our work, the admin name is showing HP, we demand say we copy. You can't say I copy because of laptop name now. But there is a way they can know you copy if you actually copy. Because drawing is just like, how do I put it? Drawing is like handwriting. You might think Shebi is computer, they won't know. This thing is like handwriting. If you are fully immersed into it, I will know that, oh, this guy copied this drawing. He did not draw. He copied. But even if we watch the same video, are you listening? I do tutorial videos on this stuff now. If you watch the same tutorial video, we follow the same step. So far, you did your own separately, and the other candidates did his or her own separately. You did not. I will know that you did not copy. Yeah, you might follow the same procedure, but from your work, I know these people did not copy. That's just it. Okay, so that's it. So if the man say you copy, and you yourself on this side, you know you copy. So it's not about He's using my laptop or I'm using your laptop. So I can use one person's laptop for 20 people's work. Here you get. So while I am not copying, I am doing it all over, even with the same step. I have no issue. That's because this software will show the time, the seconds that you actually started, the time, the amount of time you actually edited your work. Now imagine you said you don't copy, so you check the time, the same time. You check your old file, the same thing. You know, when you were updating it, changes some features, the same thing. So do you get it now? So that's how they actually know that you guys copy, and with some other stuff which I'm telling you. Okay, so take note of that. Now back to this item number 1. Okay, back to this item number 1. So taking any of the plane, I'm going to draw the circle. So the inner circle is diameter 36, the external one is diameter 54. 36 and 54. 36, 54. 36, 54. Right, 36 and 54. So after that, okay. If you look at this object from this view, that view orthographically, you know this is what you are going to have. Take note. You'll be having quite right. You're having this first circle, second circle. You'll be having this like this. Yeah. You're having Mike, shut up. So you're having this like this. Here. This one goes up like this, it goes like this. It now comes down small like this before the thing flush here. That is the orthographic view of that object from this view. So if you are not having this as a orthographic view, you are wrong. This will be your orthographic view, even though my own actually looks like a water tap. Okay, but that is the orthographic view. So if you are saying something else, you are wrong. You are wrong. So that is why I actually said you must understand orthographic view very well from your part 1, MEG 211. If you understand that very well and how to convert, then you won't have issues. You won't have problem at all. So take note of that. So I'm going to actually include that right here, somewhere here like this. So with my dimension now, okay, the thickness of this end from here to here is what? Is 15. While this inner place is what? Is 10. 15 and 10. This place is 15. This place is 10. Okay, like that. Note. Sorry, buy MTN everywhere you go. So you have network issue. Undo, yeah, Undo is sorry in Igbo language. So I learned that from Imo State. Okay, continuing. So from the midpoint, yeah, from the center here like this to the middle of this first hole here. Take note, the distance here is what? Is 50. Take note of that. Now from the middle of this hole here to the middle of this hole here, the distance here is what? Is 32. Take note of that. Now from what is the distance from this edge here to the center of this hole here? You are told that the radius from the center of this hole to this place is what? Is 12. So which means distance from here to here is what? Is 12. That's the meaning. Is 12. So interpretation of question is also very, very important. Very, very important. That is what actually makes you an engineer. Yeah, if you can interpret, so then your problem is half solved. Okay. So from the middle to that place 50 to this place 32. 32 plus 12. 50, 32, 12. That's the total length from that place. So from here to here, 50 plus 32 plus 12. Enter. That is it right there. Okay, now so from the middle Now I'm going to do some calculation again. So from here to this middle here is what? Is 12. Take note. Now from here to the back here is what? You know you are not given, I need to get it myself. But I know that from this middle, okay, if this place is 12, then this place is also what? Is also 12. That's it. This place is also 12. So from this middle also backward here is also what? Is also 12. That's it. So which means 12 plus 32 plus 12. That's 32 plus 24. That's what I'm going to actually use here. So the distance from here all the way here is 12 plus 32 plus 12. That is 32 plus 24. That is 56. If I'm correct. Yeah, I think I'm correct. That is 56. 56. The distance from that place to that back there. That's 56. Let me erase all of this. 56. So with my dimension, I put what? 56. Enter. Come. With that, I finish sketch. Yeah, I finish sketch. Let me finish my sketch. Now, okay, class has ended. Sorry, I'm not aware. Continue from where we stopped. Okay. So, can you hear me before I proceed? Can you hear me, please? If you can hear me, let me know, please. Hello? Okay. Okay, thank you. So now, the distance here is what? Is 60. Yeah, 60. So I'm going to extrude everything from here to here to be what? 60. And it's going to be what? Symmetric, like that. Okay. Alright. Do you see that? Now I'm going to click on this part here. Then what? Create a sketch on it. Creating that sketch on it. Radius 12. Remember that radius 12 stuff. So coming somewhere here, that will be diameter what? 24. Enter. Right here, diameter 24. Enter. And right here, diameter 24. Enter. Now I'm going to click on project geometry. I'm going to click on this area so that, yeah, this area can be what? Can be airtight. So with my tangential constraint, I click on this circle and this edge. You see, this circle and this bottom, this circle and this edge. Okay, this circle and this edge, this circle and this edge here. You see that? So with my line, I draw this, okay, and I think we have a circle on the inside, circle of radius. Okay, that will be, we are not given, so I'm going to assume it is diameter 12. Since we are not given, I'm going to assume diameter 12, enter, diameter 12, enter, and diameter 12, enter. You see that? So what else? I'm going to use my tangential constraint also. This circle and this line, this circle and this line, okay, already exist. This line and this circle, this line and this circle. Do you see that? So I can what? Finish my sketch now. So finishing my sketch with my extrude. I'm going to pick, let me remove all of this on 1/10 space on the outside first. I'm going to do through all, cut, then what? Like this first of all, then this hole, and this hole. Okay, that is it. Now take note, there is space here. Do you see that? And this space shouldn't be there. So there is a way you can make this space disappear. How do we do it? It is quite cheap. So I will click on this surface here and create sketch. Creating my sketch now, I'm going to click on project geometry. With the project geometry, I click on this surface. Alright, I come here, I click on this surface likewise. Then what? I right click with what? OK. Do you see that? So with that, I'm going to come to my model extrude. I'm going to click on this surface and this surface. I'm going to click on to next, then what? Okay. You can see everything is what? Clean, like what? Like Maekll. You can see clean like Maekll, fresh like fresh yoke, cheap like what? Plantain chips. Okay. So radius 9 right there. Radius what for this place here? Not given. So I'm going to assume for that area. Okay. So fillet of radius 9 first. Radius 9. So let me assume this place is radius 5. Since the height there is this thing. Yeah, that's it. So I think I'm correct. So can you see now? That's it. Cheap like what? Plantain chips. Easy as what? A, B, and what? A, B, C. That is it. Straightforward. Okay. If you have questions, ask who. If you have question, ask who. Ask your question. If you have question, ask your question. Okay. Ask your question if you have. So this is component number 1. I think. Enter. So what else do we have? Okay, we have this thing, and we have this knot. I think I should be able to pick this knot. I can pick this knot over there. But this pin, did I see this pin? Okay, I can't find this pin there. So let me just create something similar. Alright, let me just do something similar. So I won't actually do it like this. Okay, let me just do something similar so that I won't waste my time. Which one should I do? Which one should I do? Okay, let me do this. Control N. Control N. Yeah, like this. So I'm having this line here. Like this. So diameter 7.4, diameter 3.7. divided by 2. Okay, radius, the fillet there, radius 1.85. It's not having it. Okay, let me draw this to this right there. Let me trim this. Okay, let me see if my 1.85 will okay. 1.85. Okay, I think I can do this when I eventually have it. Let me get the height. The height of that pin is 36.4. Let me do 40. 40. Finish sketch. Finish sketch. I'm going to click on plane. Click on the top of this and this again. So like that, I'm going to create a sketch there like that. So a circle. diameter 3.7 if I'm not mistaken. Yeah, diameter 3.7. So I'm going to use sweep. Following that part. Then okay. Okay. So do you understand what I did just now? I beg, if you have question, ask. Okay. Okay. If you have question, ask. This will be item 6. Okay, so let us assemble. I'm going to assemble now. Standard mm.iam, then what? Create. Alright. I don't know what's wrong with my system. Why is it lagging? It's now doing like Simbi. How is it shaking? Chimpy, 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 chimpy. Okay, place. I'm going to carry everything. Put on the inside here. Check out. Don't forget, I'm going to click on this bush. Ctrl C and what? Ctrl V. You see, I've duplicated that bush like that. Do you see that? Take note of that. Take note of that. Now, so my bush is going to enter. You see, the first bush we enter here like this. If you look at that distance, this bush we enter this place. This one we enter this place. Then this boat we enter all the way coming to the outside here. Do you see that? Now, before the boat enters, sorry, before that boat enter, so this bush, this area we key in. After that, then this area we what? We go inside. After that, then this one we now enter from the outside here like this. PM. Do you see that? We enter from the outside here. PM. As it, we enter from that area like that. Okay. All right. Okay, we are given the details of this knot. So let us create this knot then. I never knew we were given its full details like this. Let us create that knot. Don't let us pick. Let us create it. Guys, let us create that knot. I didn't even see it before. I'm just saying it now. Wow. I never knew we were given details for that particular knot. So let us create this knot. Don't let us pick. Since we are given details for it, let us create. Hey, screen not being shared. Jesus Christ. I'm sharing now. I'm sharing. Is your network. If that person is saying screen not being shared, is your network. The screen is being shared. I'm sharing. Let me stop and let me reshare again. Okay. I'm sharing again. I'm sharing again now. I'm sharing my screen again. Okay. I'm sharing my screen again. So I said we should create that note. Don't let us speak since we are giving full details. Control N. Okay. With my Control N, start. So diameter 22.5. Okay. 0.819. So I'm going to use the same thing actually that I used for that edge. I'm going to use the same thing I used for that edge. So year to year, 26, 19. Okay, like that, if I'm not mistaken. Yes, it's going to be one side this time around. With my extrude, okay, right here, diameter 16 and diameter 16 and diameter 22.5. Across flat 24. So let me delete this. I'm editing this year to year is 24. Okay, extrude all through, then 0.8. I need to project geometry of this face. 0.8, like that. Yeah, like that. Okay, and I'm going to use this plane with my F7, like that. Okay, diameter 4.5. 4.5. If that is diameter 4.5, 13, 4.5 divided by 2 is going to be 2.25 plus 13. 2.25 plus 13. That is this 2.25 plus 13. 2.25 plus 13, like that. And this one is going to come here like this. 1, 2, like that. Then what? Finish sketch. So with my extrude, I can pick this. I can do it like this. True. Yeah. Then what? Okay. So do you see this? Yeah, it looks good. I'm going to duplicate it now. Oh, I think I've made a mistake. It should fall on the flat surface. Whoosh. It should fall on the flat surface. All my work is rubbish. I'm doing the same thing but on a different face entirely. It should be falling on a flat surface. Let me check it. Okay, this is a flat surface. Yeah, it should be this plane. Not the other way around. This flat plane. F7. Oh, 4.5. plus 2.25. 13 plus 2.25. Extrude, yes. Okay, so we are having it in how many sides? 1, 2, 3, 4, 5, 6. It is falling in 6 sides. Yeah, 6. So I'm going to use my cylindrical pattern. I'm going to pick this. I'm going to pick rotational axis. I'm going to pick this 6. Then what? Okay. And I have my object right there. Chicana. You see, that is it. Control S. 1, 2, 3, 4. Let me name this as part 5. Somehow, sha. So back to my assembly. Back to my assembly right here. I can place that part 5 also. And place that part 5 also. Okay. Now I'm going to use insert. With insert, I insert this to this. Like that. I insert this. So you must learn how to use that shift and that scroll button to orbit your object. It's going to make your this thing much more faster. Exactly. It's going to make it much more faster. This to this, apply. So I'm going to actually ground. Let me ground this. I'm grounding this. Okay. Grounded. So without grounded like that, I can have this like this. Maybe it's somewhere here like this. Apply. You know, this one like this. Apply. Now the hole I created here, where is it? I can't find it though. If yeah, that hole of 6 is what I'm looking for. I'm coming. Hope I haven't made mistake. 19, 13. Okay. I don't think that's the note I'm going to actually use there, actually. Yeah. Are you still with me? Are we still seeing what I'm doing? I don't think this is the note I'm going to use there. 19, it should be this. It should be this particular note. Let me reduce that height to 10 then. Oh, let me reduce the height of this one to 10. Yeah. Abi? Okay, yeah, it worked out this way. So with my, yes, I picked that for this like this, chaka and what? Okay, so with that I can swing my object like this. So that's just it. That is our object, like that. Chip like what? Like plantain chips. So that is our object in that order. That's our object. So that is the end of this particular one. So if you have any question, ask now before we call it a day. I'm calling it a day soon. Do you have any question? Any question? 1, 2, 3. Any question? Any question? Okay. Since nobody is talking, it means we are good to go. We are good to go. So I'm going to stop here for today. So I'm going to send the link of this recorded one to you so that you can go through it on your own at your own leisure time. Okay. So that's that about that. I believe you should be able to do the orthographic aspect by yourself now. That one is not that hard, Abby. Orthographic aspect is not hard though. That's the most cheapest part of this stuff. So let me just show you, Sha. So that's going to be ISO IDW. I'm just going to do the orthographic for this complete assembly view. Okay. Okay, the reason why it's like that is because of the way I actually positioned it. 1.5, slightly bigger. 1.2, very bigger. This one is okay like this. Like this. Okay, so there is nothing much there. So it's straightforward. I want hidden line to show. Okay, and that's it. Chip like what? Like plantain chips. Easy as what? A, B, C. You can put your dimension in. So you should be able to do that one on your own. Okay, so I'm going to stop here for today. Okay, so I'm going to communicate when we are going to meet to you guys later on. Or maybe, probably, so the other 3 questions, I'm just going to do a recorded video for the other 3 from my end there and forward the link to you guys. Okay, hopefully there will be light in my area. Yes, I think I should be able to finish the 3 and do everything before Friday. That's it. All right. So thank you very much for attending to this class. See you guys when you have question. Sectioning. Okay, let me show you sectioning then. I can do sectioning here also. Yeah. Let me create a new sheet. So let us assume I want to section one of the parts. Let's say part 1, like this part 1, open. So let me do it on scale of 1:1. You see now. So section, if you have to do section in best bet, show this object. Now I'm going to show this object from the plan like this. Okay. Then what? Click on my section line. My section line, I click on this area. You see, I can now pick the midpoint of that object like this. So this one is full sectioning. This one I did now is just full sectioning. So I can do several types of sectioning. So it's your choice. Okay, it is your choice. So let me show you this same object. I can section it in another way. Okay. So the purpose of sectioning is to see those areas you can't see on the outside. Those areas that are on the inside that you can't see on the outside. To see them. That's one of the purpose of sectioning. Okay. Let me show you another style of sectioning using that same object, but from another perspective entirely. Okay. So on 1:1. Like this. So sectioning. Some people were even asking for what do they call this thing? So look at this now. I can come down like this and go like this and go like this. You know, this one is half sectioning. I only sectioned this part here. You see, I only sectioned this part here. Do you see that now? So you can do several types of sectioning, several types. Now, for those who were asking for this thing during that time, auxiliary. So now I can do auxiliary view for this particular object because what, I have slant area on my plan. So with this slant area on my plan, I can generate auxiliary view. I will just press auxiliary, click on this, and what you see that face. You see, it will give me an auxiliary view. So to generate auxiliary is not that hard. Also, it is straightforward. You see that? So just click on the slant area, and you generate your auxiliary view. You see that? So you can generate auxiliary view from different perspective. Okay, from different perspective. So that's it. That's just it. So any other question before I call it a day? Any other question? Any other question? Any question? Okay. So thank you very much for attending. So hopefully they'll be like, this video should be ready before tomorrow. If not by tomorrow, it should be ready, alright? So thank you very much. See you when we see. Bye bye.